Now that we can find our stationary points, let's look at the different types of stationary points. First of all, let's look at this graph. Now, from our work before, we could see that there is going to be a point at the top here, which is going to have a derivative that is going to be equal to 0. But we can also see that at either side of this point, the derivative on this side here is going up to this point. So it is going to have a positive derivative. And on this side here, it's falling back down and it will have a negative derivative. This is what we call a local maximum. Where the derivative prior to the stationary point is positive. Then we have the stationary point, and then after that point we have a negative gradient. As you can see, it sort of reaches a maximum before falling back down, hence the name of a local maximum. So, looking at the next type of stationary point, let's look at the graph. So, our stationary point is going to be at the bottom here. Then we can see that prior to this, we're going to have a negative derivative going down. After it, we're going to have a positive derivative. And we call this a local minimum. We can see that the shape goes from a negative gradient to our stationary point, going to a positive gradient. Hence, it shapes down and is a minimum point. These are local maximums and minimums, mainly because we don't know the rest of the graph. So they may actually not be the lowest or the highest point in that graph. The third type of stationary point is called a stationary point of inflection. Now this occurs at a turning point on the graph. So like on an x cubed, you've got a flat bit before it continues going up. That point there on a cubic is at x equals 0. And the gradient at that exact point is 0. Now it's a point of inflection mainly because our sign of the slope does not change either side of the stationary point. So looking at that, we have a positive derivative after it and a positive derivative prior. It could also work in reverse. So looking at that, if we had the reverse of that cubic, oops, not a very good cubic there, hang on. We would still have the same stationary point through the middle, but we would have a negative derivative prior and a negative derivative after. Both of these are points of inflection. They come from the fact that we have the same sign before the stationary point and after the stationary point. Those are our three types of stationary points. So these stationary points and their classification, whether it's a local minimum, a local maximum, or a point of inflection, help us draw graphs. So let's look at doing that. Let's look at the function equal to x cubed minus 3x. So, what's our first step that we need to do? Our first step would be to find the derivative. So f prime of x is going to be equal to 3x squared minus 3. To find our stationary points, we will set this equal to 0, which would get us, taking the 3 over the other side, dividing by 3, would give us x squared is equal to 1, so then x equals plus or minus 1. Now, before we go and find those stationary points, let's find out what type of stationary points they are. The easiest way to find the type of our stationary point is by doing a graph. So we put our point in the middle, and we're looking at either side of it, specifically the derivative, and then we can write in what's happening with the line. So we know that when x equals minus 1, the derivative is going to be equal to 0. Now, choosing a point either side of it, so we'll look at the positive side first. Let's choose a point that's greater than... Now we need to choose a value for x either side of our... Now we need to choose a point either side of our stationary point at x equals minus 1 that would be able to tell us the shape of the curve. The easiest one, I would say, on the positive side would be when x equals 0. Well, when we put that up into our derivative, we can see that x equals 0 would just leave minus 3, so it is going to be a negative value. From that, we know that the line, or the shape of our graph, is going to be going down. Next, we have a looker point to the left-hand side, or a more negative number. So let's choose just another one, minus 2. And that from there we can see that minus 2 squared is going to be 4, 4 times 3 is going to be 12, minus 3, it's going to be positive. From that we can see that the line is going to go up. Just from that, we can see that this point, wherever it is on our graph, is going to be a local maximum. So now, let's do it for when x equals plus 1. Doing up the same graph. We already know that the derivative at 1 is going to be equal to 0. So let's have a look at the points at either side of it. Well, we already know that on the lower bounds, the 0 is going to be negative. So we can put that straight away in. Now let's have a look at on the other side. So when, let's say, x equals 2. Well, that's the same thing as on the other side, mainly because minus 2 squared is the same as plus 2 squared. So that's going to be positive. So we're going to end up with a local minimum. From that, we can already see the shape that's going to be occurring on our graph. So now let's look at let's determine where those stationary points are. So what we do is then just put our values for the stationary points into our original function. Which is going to equal 2. And then f of 1 is going to equal 1 cubed minus 3, which is going to equal minus 2. So then we know what our stationary points are and where they are on our graph. So we're going to have a local max at point -1, 2, and a local minimum at 1, -2, which makes sense when you look at where those numbers are positioned anyway. Our next step is to find where the graph crosses the x and the y axis. So the graph crosses the y axis when x equals 0. So putting that in gets us 0 cubed minus 3 times 0, which is going to equal 0. To find our x-intercept, we need to find when f of x is equal to 0. So that's when x cubed minus 3 times x is equal to 0. We can do this by a little bit of factorization. So that gives us x outside of x squared minus 3. So again, by our same sort of steps, we can look at when this is going to equal 0. Well, that's going to be when x equals 0. So that's where they both cross. And we saw that when we looked at our y-intercept. Now we look at this when x squared minus 3 is going to be equal to 0. Well, that means that x squared is going to equal plus 3. So that is x is going to equal plus or minus the square root of 3. So now we have all the information we need to draw the graph. I'll just make some space here. So looking at this, let's get our line down. Now we know that it's going to cross when x is going to be 0 and y is going to be 0. We know that it's going to cross at plus square root of 3, and it's going to cross at minus square root of 3. We also have stationary points occurring at -1, 2, and a stationary point occurring at 1, -2. Our next step is that we know that at the point -1, 2, we have a maximum, and that we have a minimum at 1, -2. So this is our graph for our function f of x is equal to x cubed minus 3x.